This is Algebra 2, Chapter 12, Section 7, in which we will study graphing trig functions. Okay. To be able to do these graphs, they're going to ask us about several details. They're going to ask us about the amplitude. That's one of the things we have to learn about here. When we talk about an amplitude, all we're talking about is half the difference between the top and the bottom. Okay, the maximum value and the minimum value. Half of that difference is the amplitude. Okay. One way to find it is to draw a line across the middle of the graph and then measure from the middle up. Another option is measure from the top to the bottom and take half of it. Either way, you get to the same result. Now, among the periodic functions that we know, sine and cosine are the big ones. They're the ones we're going to work with the most. Okay. The values that we see written in the function tip us off to things about the amplitude and the period. Whether we're looking at a sine b theta or a cosine b theta, either way, the amplitude is going to be the absolute value of the a number, whatever number's in front of the trig function. The absolute value of that, that's your amplitude. Your period for the function is 360 divided by the absolute value of the b number, the number that's inside the sine or the cosine, right in front of the theta, or the x, depending on which problem you're looking at. If they want you to work in radian mode, then it would be 2 pi over the absolute value of the b number. Okay. For my money, I don't care which one of the two you work in. Probably want to be consistent unless they give you something specific. Or they say, nope, we want radians here, then do what they say. So let's find a couple of amplitudes and periods just to make sure we know what we're talking about. Okay. Y equals -2 cosine of half theta. Well, the amplitude is the absolute value of the a number. The absolute value of the -2 is 2. The period is 360 divided by the absolute value of the b number. The b number is a half. 360 divided by 1/2 is 720. So we found our amplitude, we found our period. Okay, let's try another one here. This one will involve sine instead of cosine, but that's the only thing different about it. The amplitude is the absolute value of a, so the absolute value of 3 is 3. The period is 360 divided by the absolute value of 5. The absolute value of 5 is 5, so 360 divided by that is 72 degrees. Now, related to the period, there's another idea called frequency. Right? The frequency of a periodic function is how many cycles occur in a given unit of time. Right? How many, for lack of a better word here, how many waves do you see over a given amount of time? When that amount of time is specifically 1 second, then frequency is measured in something called hertz. And the symbol for that is capital HZ. Okay. Your radio frequencies are measured in, if you're on the FM dial, they're measured in megahertz. If you're on the AM dial, they're measured in kilohertz. So you've been using hertz, you just didn't realize it. And the easy way to find the frequency is it's the reciprocal of the period. So let's look at an example here where we write our own function. As humans, we can hear sounds down to a level of 20 hertz. If the frequency is 20 hertz or more, up to 20,000 I think is the upper end, then we can hear the sound. All right. Our job is to first find the period, and then they want us to write a cosine equation with an amplitude of 2 that would simulate or model these sound waves. Well, if the frequency is 20, then that means the period is the reciprocal of 20 hertz. 1 divided by 20 is 0.05. All right. If that's the period, we can now figure out B. The period equals 360 over B, multiply by the B, and then divide by the 0.05, and we find out that B is 7,200. They told us A right here, the amplitude is 2, so that'll be a good value for A. So Y equals 2 from the amplitude, cosine, because they said to write it in cosine, of 7,200, that was our B, and then we use T per time. You know, you could use X or you could have used theta here. I just picked T this time. So there's our function, as pretty as it gets. Okay. The other 4 trig functions, remember we've talked about 6 here. Sine, cosine, tangent, cotangent, secant, and cosecant. Sine and cosine have amplitudes, the other ones don't. Okay. So if they ask you to state the amplitude of the cotangent function, it doesn't exist. It's no solution. Okay, there's no such animal. We can still, however, figure out their periods. For tangent and cotangent, it's 180 divided by the B number, or pi over B if you're in the radian mode. Of course, absolute value of B there. Secant and cosecant are like sine and cosine. They're 360 over the absolute of B. 2 pi over absolute of B if you're in radian. Okay. You'll notice on your note sheet here I left you some space at the bottom of the page. You will probably find it useful to have the parent graphs of sine and cosine and the other 4 into your notes here, so that you'll have those handy for easy reference. So I would, if I were in your position, I would put those into my notes in that blank space down there. You'll find sine and cosine on 837. You'll find tangent on 839, and you'll find the other 3 on 840. Now, if they just ask us to make the basic parent graph, we can do that, because we'll have that right there in our references. Any of the other ones, instead of going through all the hassle of making a T-chart, plugging in values, grinding out answers, and then plotting it, we're going to let the graphing calculators do the heavy lifting for those things. And when we get to class here, I will be having you get the graphing calculators, and I'll show you how to do that based on the function that they give us. But other than that, you'll still be able to find periods and amplitudes and frequencies. So if you had questions along the way, hopefully you wrote those down. Bring them in with you, and we'll see you in class.